So begin our discussion on the design issues of data link layer. Okay, so this is let me write. The topic is data link layer. In our earlier video, I already told you there are two parts. One is logical link control and media access control. So essentially in this we are going to look at the issues of LLC, issues of logical link control. So what are the issues? As I mentioned in my earlier video, the important functionality includes framing, error detection and correction, elementary data link layer protocols for achieving this functionality, and there is another set of protocols called sliding window protocols. So that is the learning objectives of this particular chapter. The data link layer uses, this is a summarized discussion of whatever I discussed in my earlier video. The data link layer uses the services provided by physical layer and render services to network layer. It has number of functions including well-defined interface to network layer, dealing with transmission errors, regulating the flow of data so that slow receivers. This is nothing but I told you earlier, the problem of flow control. This is a problem of flow control. Look at that. Regulating the flow of data so that slow receivers are not swamped by fast senders. Swamping means getting overflow and losing the data. Overflow and losing the data. So this will lead to loss of data. Loss of data. This will lead to loss of data. I'll write it again. Loss of data if they are not managed. So dear students, so at this point of time, this could be a simple 2-mark question from your exam. Enumerate what are the functions of data link layer. So you have to talk about from the previous slide and this slide. These are the functions carried out by. So design issues implies nothing but the functionality. This is nothing but the functionality of data link layer. Errors may happen over communication channels. So to deal with that, we have error detection and correction. Okay, and then providing services to the network layer, that is the functionality, and then the regulating the fast control and fast render and slow receiver, that is called flow control management. Okay, to accomplish this goal, the data link layer take the packets that it gets from the network layer and then encapsulate them. I described this process. I am showing it diagrammatically in this presentation. Have a look at it. So from the network layer at the sending machine, I receive a packet. I encapsulate that packet in the payload field of, this is a frame now. So frame will have the header, the trailer is also called checksum. I told earlier checksum. In the payload field, I will put the packet. So this become a frame which is transmitted onto the physical channel, and the receiving machine will receive as it is. Framing is done, and then the payload will feed after error detection and correction. After ascertaining that everything is fine, we'll hand over the packet to this. If there is any problem, then we'll send it back saying that we didn't receive the frame properly. You resend again. So that is error management. Okay. Error control, flow control are found in transport and other protocols also. This is because reliability is an overall goal and it is achieved when all layers work together. That is true. Okay. Now what is framing? The first functionality. As I said, the sending data link layer will send the frames to the physical layer. The physical layer will break the frame into bits, and the bits get transmitted over communication channel. So if you assume diagrammatically, this this is a communication channel, this is a receiver. So this will send the bits onto the stream, onto the media, and then this will also receive the bits. This is the physical layer here. So physical layer will hand over these bits as it is to data link layer. So data link layer will have to perform what is called framing. That is breaking up the bit stream into units called frames. And that general frame structure I already told you earlier. In the earlier slide I have shown you. So earlier in this frame format, it should get it. Okay, so how to do framing? That is what is the actual objective of this particular topic. So when a frame is to be transmitted, look at that. The source machine does the following. What will it do? It will break up the bit stream into discrete frames and compute a short token called a checksum. Checksum will tell how to calculate the checksum for error detection. Okay, include the checksum in the frame when it is transmitted. This is done by the sender. Then what will the receiver do? When a frame arrives at the destination, the receiver machine does the following. The checksum is recomputed of the arrived data stream, the checksum is recomputed, and if the newly computed checksum is different from the one contained in the frame. This checksum is what? Checksum is nothing but information about the errors, right? About the data. So if the checksum, which is already, see, the frame is already having three things. One is header, the other is payload, the packet, and the checksum, trailer. This is called checksum. So the sending machine will compute the checksum and put the value here. Then it is in transit. Now when it comes at the receiver side, what the receiver will do is for this payload, it will recompute the checksum again. That is what we are saying. Whatever information I got here, I will recompute the checksum. That is what is the meaning, recompute. And then the newly recomputed checksum is compared with the already stored checksum here. Got it? Already stored checksum. So if both of them match, then that means the data is intact. Otherwise, if there is a mismatch, then that means the data got garbled, the data got corrupted. How to compute the checksum? What are the approaches? We are going to discuss later in detail as algorithms. Now the data link layer knows that an error has occurred if there is a mismatch and then takes steps to deal with it. I mean, if a bad frame comes, what are we going to do? Are we going to retransmit? Are we going to request for retransmission? There are different approaches followed in different protocol we are going to learn. So this is the meaning of error detection, error correction with checksum, error control with checksum. Now generally how framing is done. Now this is an important topic from your examination perspective, and also you can write programs for this. I'm putting at star topic. You can write program for this, and this could be a simple 5 or 10 mark question, 10 or 5 mark question. All right. So you can expect a question and problem also based on this approach. So learn these algorithms, 4 algorithms, out of 4, 3 are based on problem solving and is general theoretical. So you need to familiarize yourself very clearly with 4 framing methods. One is called byte count, the other is called flag bytes with byte stuffing, and the other is called flag bits with bit stuffing. These 3 are essentially important. This is of course a trivial one. Trivial means not that important, but we will study about it also. So let's take up next the first one, framing, the first algorithm of framing. Framing using byte count. So what happens here? The byte is what? Group of 8 bits, byte count. That means we specify in the frame how many bytes are there, specify the number of bytes in the frame. This framing method uses a field in the header to specify the number of bytes present in the frame, 10 bytes, 20 bytes, 5 bytes, like that. When the data link layer at the destination, look at that, when the data link layer at the destination sees the byte count, it knows how many bytes follow in that and hence where the frame is going to end. See, essentially the objective is we should be able to distinguish where is the frame starting and where is the frame ending, so that I can take that as one unit and hand it over to data link layer for further processing. That is the meaning of it. Okay, just to also again understand, when the data link layer at the destination sees the byte count, it knows how many bytes follow and hence where the end of the frame is. To understand that, let us consider, and then I will come to drawback. Look at this. This is a simple example to show the working of byte. So frame begins with a count of the number of bytes in it. Simple but difficult to, okay, we'll see about this. So look at this. Let's understand here. So this is my stream of binary bits, you can say, represented in the form of decimal digits. So what is the first parameter indicating? 5. What does that mean? My first frame has 5 bytes. My frame size of the first frame is 5 bytes, including that. So 1, 2, 3, 4, 5. So this is frame 1. End of the frame. And now what is the next number? Next number also again indicate what is the size of the frame. Again 5. So therefore starting from here, 1, 2, 3, 4, 5, the second frame. Next, what is the byte count? 8. So starting from here, 8 bytes are used as a frame, third frame. So 1, 2, 3, 4, 5, 6, 7, 8. This is the third frame. Frame 3. And like that, this is another 8, this is the fourth frame. So that's how we distinguish with byte count. The major problem with byte count is, for example, imagine during the transmission, if the byte count itself get into error, this value get into, by mistake from 5 it got changed to 6, by mistake of 5 it got changed to 7, then don't you agree that it will do the framing in a wrong way? Like for example, here it says this byte count instead of 5 got changed to 7. So instead of taking 5 bytes, it will take 7 bytes. 1, 2, 3, 4, 5, 6, 7. And next it will take it as this as 1 byte, only this one. So whole thing will get lost, So what does it say? It is simple but difficult to see resynchronize. So here resynchronization will become difficult when an error occurs, especially with respect to, that is what it says. Trouble with this algorithm is that the count can get garbled by a transmission error. It will then be difficult to locate the correct start of the next frame. So the whole thing will get lost if the byte count get garbled. I hope you understood the mechanism of byte count. Okay, framing byte count, first method. Now what is the second approach? Second approach is called byte stuffing. What is byte stuffing? So let's read the algorithm, then I will explain by means of example. Please follow. The flag bytes with byte stuffing. That means we are going to use one special byte, one special character, one special byte called flag. Special character. Like there are so many special characters available in every encoding technique. So one special character by name flag is taken, and that is used as the starting and ending delimiter. Please understand. So if I have a frame with characters like A, B, C, D, then I will use this flag as a special character at the start and at the end flag. That is meant by start and end delimiter. Got it? So every frame will be encapsulated with the special flag byte to indicate the start and end of the frame. That is the meaning of the first statement. And often the same byte called a flag byte is used as both the starting and ending date. Yes, that is the same byte. Okay. So now there should not be any problem of resynchronization which was happening there. Now what happens here? Two consecutive flag bytes indicate the end of one frame and the start of the next. And to differentiate between byte pattern and data, a special escape byte is inserted. Now what is the meaning of this escape byte and all that we will see. A major problem that may happen is this flag byte also sometime it may happen to be part of data. Then what are we going to do? Meaning if a flag byte occurs within part of data also, like for example I may have A, B, C, D, then flag, then again A, B, like this is my data. This special flag is occurring as part of data. Then how are we going to resolve? To understand that, we will see the example. Let us see. So point, what does the figure A saying? This is the convention approach. This is my frame. The frame starts here. It is delimited by special flag byte. So it is a general format. Now suppose for example, as I said in my data, this is my original data. This is my original frame. So within the frame, this is the character A, this is character B, and flag is also occurring. Flag is also occurring as part of this. So how to differentiate? Because this will be preceded by actually two flags. Flag, as per this concept. But what happens now, because of the presence of the flag, mistakenly the receiver may consider this as the frame. Because the flag is encountered here. But this flag is not the ending. This flag is not the trailer. It is not the end delimiter. The frame is ending here. The frame is ending here with this flag value, but this flag is occurring in the data stream and creating the trouble. So to prevent that problem, what the algorithm says, use a special character called escape character. So in the frames, in the data, whenever I say escape character is stuffed, escape character is encountered, and escape is followed by flag, then in that case, what the receiver will do is so this is called stuffing the character. We are stuffing this special character escape to indicate that flag is not the delimiter, but flag is also part of data. This is called byte stuffing. We are stuffing this byte. We are putting this byte. So again I repeat, in case if the flag also become part of data, to distinguish that it is not the starting and ending delimiter, we stuff a special byte character called escape character to distinguish that the flag value followed by escape character is not the trailer, but rather it is part of data. So escape followed by flag, escape will be removed, escape will be destuffed at the receiver, and we continue. I hope you are getting my point. Now sometime problem will happen. Escape character may also become part of data. So this is my original data. So escape is occurring here. So in that case what we do, we follow the same protocol. We stuff another escape character. So escape and escape. So this escape will be removed by this and this will be taken as data. It is not delimiter, right? As a special case, I can have this as my data. Look at this. A, escape, flag, B. So this is the data. So in the beginning, I will have the flag delimiter, ending will have flag delimiter. But to distinguish this, what are we going to do? Now for this escape, we put one additional stuff character. And so and for flag also one additional escape character. So what will be the final content? Escape, and this escape originally as part of data, and then because I am having a flag as part of data, so I add another, I stuff another escape character, and this is part of my data. So here I will have flag and here I will have flag, meaning before the flag character, if I have the stuff byte as escape character, then that flag will not be taken as delimiter. That is the point. As another example, take this. Suppose if I have two escapes, then how many bytes we need to stuff? One escape for this, one escape for this. So totally how many I will have? 4. So this is the stuffed, this is actual, this is the stuffed, this is the actual. So this is part of data, this is part of data, this escape will be removed, this escape will be removed at the receiver side. This approach is called byte stuffing to distinguish between different frames. So again, I repeat in summary, every frame will be delimited by starting flag character and ending with flag character, start and end delimiter. But it may happen that the flag itself may become part of data. In that case, we stuff a additional byte character called escape character. So if flag is part of data, then flag will be preceded with escape character, so that in the data stream, if we encounter escape, we destuff that and the flag following by that will be taken as part of data but not ending delimiter. But sometime it may happen that escape may also come as part of data. In that case, we add additional escape character. So again, we follow destuffing. Okay. And then these are the other two combinations. So I hope this algorithm is also clear to you. So a problem can be expected here. I can give a simple 2-mark question. I can give some data stream and I will ask you, show after stuffing, how does that look like? I may give this data, you will have to indicate this. I hope the problem is clear. Okay. Now the other last approach for dealing with framing or framing method is called bit stuffing. Earlier was byte, this is bit. So we talk about bit. So what happens here? We are going to use a special flag pattern, 8-bit pattern. These 8-bit flag bits with bit stuffing. Each frame, look at that, each frame begins and ends with a special bit pattern, 8-bit pattern like this. So special bit pattern is going to act as the starting and ending delimiter again, starting and ending delimiter again. Let me change the ink. Starting and ending delimiter. This flag pattern. The third method of delimiting the bit stream gets around a disadvantage of byte stuffing, which is that it is tied to use of 8-bit bytes. So this special bit pattern is again 8-bit bytes. Each frame begins and ends with a special bit pattern I told just now. It also ensures a minimum density of transition that help the physical layer maintain sync. Okay, I mean slightly better than the previous approach that he's trying to say. So here I will try to show you the algorithm of bit stuffing. So whatever bits of data I have, like for example, if I have a bit stuffing like this 10 10 11 0 1 1 1 0, something like this is my data. So this data will be delimited by this special bit pattern called 0 1. How many ones? I have 6 ones. Look at that, 1 2 3 4 5 6. Correct? 6 ones. Like this. This is a starting delimiter. And the ending delimiter will also be 1 2 3 4 5 6 0 end. In between I will have the frame. So receiver, when it starts, first it starts collecting 0. If 0 is followed by 6, followed by 6 once, followed by 0, then it will consider this as start of frame, and then end once it says, so it takes all this as one frame. Start, end, and delimited within that we have frame. But problem is during the data or in the data stream also, sometime it may happen that I may get this flag pattern. Then how are we going to resolve? To understand that, let's take an example. Look at this. Imagine, for example, this is my data. Here I have written the original data. But what is happening here in the original data also, I have, for example, a series of bit patterns with 6 ones. And sometime it may happen that 6 ones may be followed by 0 also. Then how are we going to resolve that problem? The resolution is done by the concept called bit stuffing. And the algorithm of bit stuffing says that, right, it says that in the data stream, whenever I get 5 consecutive ones, then we add 1, we add 0 bit. Like, to understand that, let's take this. So here as it is, I will have 0 1 1 0, and look at this, I have 1 2 3 4 5. So 1 2 3 4 5. After 5 we are stuffing this additional bit to distinguish, so that Because what is the flag pattern? The flag pattern is, look at that, the flag pattern is 6 ones followed by 0. So to prevent that flag pattern happening in the flag pattern happening in the data stream, so after every 5 consecutive ones we stuff 1 bit, and after every consecutive 5 bits I stuff another bit, after another consecutive 5. So 3 bits have been stuffed, 1, 2, 3. So now the rule becomes very clear. So in the beginning, when the data is transmitted, I will have the flag pattern with 6 ones followed by 0. So 6 ones followed by 0 will never happen in the data, because the rule is after every 5 ones in the data we are putting 1 0. So in the beginning delimiter, the receiver will receive this and take that, okay, the next thing followed by is the data part. So in the data part, what happens is after every consecutive 5 ones, if it find a 0, it will destuff that and again continue 5 ones destuff. So after destuffing, this is what sender will send, and then when the receiver receives it, receiver will destuff these zeros and get back the original stream. This is called bit stuffing. So 3 methods: counting method, byte stuffing, bit stuffing. These are the 3 where you can expect problems. You can expect 2 marks or 3 marks problem. Again, verify. This is a counting method. Frame byte count we are putting. Okay. Problem is if the byte count get corrupted, then the data is lost or it get desynchronized. And then the byte stuffing. So what happens? We use a special character called flag bit to indicate the starting and ending delimiter. But it so happens that in the data stream itself, I may encounter flag. To distinguish that, we add an additional character called escape character. Okay, so for every flag present in the data, we stuff this escape character so that the receiver at the receiving end will remove this escape character preceding with flag. But remember, the ending delimiter flag value will not have escape. That is the meaning. That's how we distinguish. Starting and ending flag will never have escape character. Remaining all will have escape character. So whenever in the data stream, whenever it see that the first one is flag without any escape, so this is a start. Then it see that, okay, escape means whatever flag, that is part of data. That is the meaning of it. Sometime it may happen escape will also become part of data. So I will add another one. So escape followed by escape, one escape will be removed at the receiver side, and like that it goes. Then the next thing is the bit stuffing concept. So we use a special bit pattern called 0, 4, 6, 4 ones, 6 ones followed by 0 as a flag pattern. In the data stream also I may encounter the same flag pattern. So the rule which is generally followed is after every 5 ones in the data stream, you stuff one additional 0. Okay, so 6 ones will be followed only in the starting and ending delimiter bit pattern. It will never happen in the data stream. So that's how the sender and receiver will agree upon this protocol for demarcating the binary stream of data into frames. So these are the 3 approaches, and the 4th approach I said for reserved signals. So what happens in this? The physical layer coding violations. That means we use some reserved signals, some special signals to indicate the start and ending frame, because the data that get transmitted on the communication channel is by means of signals. So for regular 2 types of signals, I will have signals for representing data, signals for start and end delimiter. Like for example, I may say in the regular approach for data, I may use +5 voltage and -5 voltage for 0, 1. For starting and ending delimiter, I may use like +3 voltage to -3 voltage. So by means of the signaling, signal levels, we can demarcate, we can differentiate between different frames through the special signal. That is what and generally the last comment is the data link protocols use a combination of these methods for safety purpose. So this is the chapter on framing. There's a topic on framing. So practice this. You can expect some problems, or you can expect a direct 5 or 10 mark question on framing as such. Okay.